If everything goes as planned, Tianwen1 will be the first mission in history to successfully study the red planet with an orbiter, lander, and rover. And what is their mission and how can they do it? Last time we walked you through the landing process known as 7 minutes of terror. And after that, China's Mars rover will make its debut. It will extend the 4 solar panels in the shape of butterfly wings and trundle off the ramp on the lander. It's expected to explore the surroundings for at least 90 Martian days, or roughly 3 months on Earth. It will use the orbiter as its communication relay with controllers on Earth. For any scientific mission, power is the first concern. The rover starts work during the afternoon when the temperature is highest, so it can store energy for the night shift. But just 30% of the solar energy can be converted into electricity, so there is the power innovation, a chemical called undecaying. It will absorb solar heat and melt during the day and release the energy and re-solidify during the night. 80% of the heat will be stored. Well, the Chinese team has identified 2 potential landing areas for rover, at here and here. North of the equator on the plains of Utopia Planitia. It's believed to have been a giant ocean in ancient times. It is flat and smooth and has good sunshine. Many previous rovers, including 2 Vikings, Pathfinder, and Perseverance in 2020, landed nearby. And most importantly, you want to land close to your research area. Well, Tianwen1 will carry out a comprehensive study on Mars. This includes an overall inspection on a global level and a targeted research in specific areas. 13 instruments are involved, and 6 are fitted on the rover and 7 on the orbit. That's right, the orbiter will not only act as the communication link, but also needs to move to a closer orbit to survey the planet for an entire Martian year, or roughly 23 months. The orbiter will use this vantage point to check out the wide view. With a high-resolution camera and radar, it will map the surface and characterize its geological structure, searching for water and ice, as well as rock distribution. The rover will study the soil composition and look for evidence of underground water. It also needs to collect atmospheric data to document climate change. These are all elements in determining the so-called habitability of Mars. Similar scientific instruments could be seen in previous missions to Mars, but Mars is so big and so much of it is unknown to us. Given that China's rover will explore an area never reached before, any data collected will definitely deepen our understanding about the red planet. Along with Tianwen1, missions by the US Perseverance and the UAE's Hope will also be carried out in July. The Hope satellite is to launch on the Japanese rocket. Given the COVID-19 travel restrictions, the UAE had to deliver the satellites to the Tanegashima Space Center ahead of schedule to avoid missing the optimum launching window in mid-July. Hope will only orbit Mars and focus exclusively on the Martian atmosphere. The lower atmosphere can reveal the climate change, and exosphere may tell us how and why oxygen and hydrogen escaped. The UAE also chose a unique inclined orbit, which will offer a chance to study Mars the whole day rather than at a fixed time. Mars exploration pioneer NASA is sending its latest car-sized robot Perseverance to search for signs of microbial life. It will be sent to an uncharted Asian lake bed crater and will drill for rock and soil core samples. The sample will be stored in 43 tubes. The plan is for the samples to be taken back to Earth in a future mission. Scientists will then check whether they contain any organics material, which would be really exciting. By the way, Chinese officials have suggested that if Tianwen1 and later on the Chang'e 5 moon missions go well, China could attempt to collect and return samples from Mars beginning around 2030. Also, Perseverance will carry the helicopter drone for a test flight on Mars.